This is GCSE probability, and we're going to start then with a little bit of relative frequency. So you should be able to find the probability of an outcome using given data. Relative frequency is the number of times the event happens in the experiment or survey divided by the total number of times the experiment or survey took place. The relative frequency can be used to estimate how many times an outcome would be expected. A record which kept the football team results after every 20 games. And part A then down the bottom, which you can't see, is calculate the relative frequency after every 20 games. So let's just work our way through that. It should be straightforward enough. So this one's going to be 9 divided by 20. If you put that into your calculator, 9 divided by 20, you will end up with 0.45. Next one is 14 divided by 40. You will end up then with 0.35. Next one then is 17 over 60. And I'm going to have to start using the calculator then for this one. That's 0.283 to 3 significant figures. Next one is 23 divided by 80. Which is 0.288. Next one's 25 divided by 100, which is of course 0.25. Next one is 25 divided by 120. Which is 0.28. Next one, 26 over 140. Not 0.186. 33 divided by 160. 0.26. 37 over 180. Maybe there. 0.205 recurring, so it's going to be 0.206 again. And then 41 over 200. Is 0.205. So that's where we are. Those are a relative frequency. That's the probability then as you start to work them out. Let's see what the questions asked us. Which of these gives the best estimate for the probability that the team will win their next game? The more data we have, the more accurate it's going to be. So if we look back to our previous page, this one's over 200 games, whereas this one here is only over 20 games. So this one here, so 41 over 200, gives best estimate. Using this relative frequency, estimate the probability of a win to estimate the number of wins the team might expect in the next 100 matches. So we have 0.205, which is of course or 41 over 200, and if we multiply that by the 100 matches, we're going to get 20.5, and so we would expect then rounded just the nearest whole number. Explain why this is only an estimate. I mean, all of these things are obviously just estimates. This is just kind of, we're taken from the previous data. Anything could happen within the next 100 games, and so you're never quite sure the way it's going to go, the way the probability works. Just because a football team are very likely to win, for example, if you have a very good team against a very bad team, you would expect the good team to win, and they're probably going to win maybe 8 out of 10 times. However, it doesn't always happen. So it's only just your best guess, and that's all we can do, and that's the way our relative frequency works out. On to the next wee topic then, a very straightforward one as well. I hope for you the probability of an event not happening So probability of an event happening plus the probability of an event not happening equals 1. To find the probability of an event not happening, subtract the probability of it happening from 1. Probability it rains tomorrow was 16 over 25. Find the probability it will not rain tomorrow. So the probability not rain tomorrow equals 1 minus 16 over 25, and that then gives me 9 over 25. Doesn't get much more straightforward than that. I hope we're okay with that. Next then on to mutually exclusive events. You should be able to find the probability of combined outcomes which are mutually exclusive. Mutually exclusive events are events that cannot happen at the same time. For example, getting a 2 and a 5 and rolling a fair dice. Events A and B are mutually exclusive when A or B equals the probability of A plus the probability of B, or means add and probability. Definitely a good wee rule to remember. When events are not mutually exclusive, we need to list desirable outcomes on all the possible outcomes to find the probability. A bag contains 6 red, 8 green and 12 white beads. One bead is drawn out at random. Find the probability that it is red or white. So probability of red or white, again nice and straightforward. Because they're all equally likely, because they can't happen together, we can just then add a probability. So 8 plus 12 gives me 20, plus 6, there are 26 different outcomes, and red or white is going to be then 18 over 26. This gives me a probability then of 9 over 13. Example 2, the probabilities of a spinner landing on each number are given in the table. What is the probability of getting a 1 or a 3? So the probability of a 1 or a 3 is of course going to be 0.14 plus 0.11. That gives me 0.25. What is the probability of not getting a 2? Alright, these things as part A. The probability of getting a 2 is 0.23. Therefore, the probability of not a 2 is 1 minus 0.23. And that gives me 0.77. The other thing you could do, of course, is add those other 5 up. That should give you the same thing. What's the probability of getting an even number or a prime number? Our even numbers here, of course, are 2 and 4 and 6. Our prime numbers, of course, are 2 and 3 and 5. So what numbers? We have 2, 3, 4, 5 and 6. So what's the probability of getting an even number or a prime number? So a 2, a 3, a 4, a 5 or a 6 will give us what we want. So all we want is not a 1. The probability of even, you just about see that here, or prime is 1 take away 0.14. I hope you can see how I'm doing that. The other thing you could do is just add those ones up, but I think this is a more convenient way of working it out for us, and that's going to give me 0.86.